Welcome. So this video serves as a revision tutorial video for the first test, the 40% test. So what we have for your assessment, we had the first assignment worth 15%, the second assignment in class is worth 25%, this test is worth 40%, and it's on a little bit of the class, the systems of differential equations. It's on chapter 2 and chapter 4, and then finally you've got a 20% test based on chapter 1 to come last. Okay, so we'll just go through the exam questions. So the first one, if you go to page 229 of your manual, remember, as usual, you can always pause this video and email me questions, no problem, I'll get back to you. So there's, as I said, there's the chapter 2 question, the chapter 4 question, and the systems of Laplace. So systems of differential equations using Laplace transforms. So the chapter on Laplace transforms, not everything was in the assignment. There's a final section that wasn't in it, and that will go into this test. Okay, so this question, which is question 4D on last summer's paper, it can either be heat exchange between two objects in thermal contact, in which case you kind of write down two Newton cooling differential equations, or it's this salt brine cascade. Now the heat transfer question is more difficult. The salt cascade one, now I'm just doing whatever came up in the 2019 paper. You could have the heat to thermal exchange one where you need, when you write down the, what I'll do is I'll do this, actually I'll tell you what I'll do this question using the methods that you need for the other one. This can be done slightly easier. Okay, that's how we'll do it. Okay, so ultimately anyway, you have a system of differential equations. So two differential equations, say dx dt equal to minus a half x of t, and there's an initial value of x is equal to 2, and then do y dt now what this is you've got a water source. There's a tank with salt water, another tank with salt water, and so much of the water is flowing into the first tank and flowing into the second. What's happening, x is the amount of salt in the first tank, y is the amount of salt in the second tank, and a certain amount, because this is negative, the amount of salt is decreasing in the first tank because fresh water is flowing in, and everything that's flowing out of the first tank goes into the second tank. That's for this plus, but it's also flowing out of the second tank. Okay, and there's an initial value of y as well. So if it's heat exchange, there's also a y here. This particular one is a bit easier to solve because you can solve the first one. It's actually an easy differential equation to solve, and then what you can do is you can either substitute in the x of t in here once you've solved for x of t, or after you've done the Laplace transform you can substitute in big X of s. So actually this one is not too difficult. Now the other one, you end up with x's and y's, and I recommend that you write it as simultaneous equations, as a matrix equation, and use Cramer's rule, and that's what I'm going to do on this example, even though it doesn't need it. Okay, so I'm going to do it as if it's the harder problem than it is. So you got simultaneous differential equations. Now the question, in fairness, it says use Laplace transforms, but what you're going to do is turn the simultaneous differential equations into simultaneous algebraic equations by taking the Laplace transform of both equations. So at this stage it should be quite easy for you. So the first derivative gets sent to s times big X of s minus little x of 0 equal to, fix the minus a half, and little x of t gets sent to big X of s. Okay, and also do the Laplace transform both sides here. So dy dt gets sent to s times big Y of s minus little y of 0 equal to, fix the half here, fix the minus a quarter, and little y of t gets sent to big Y of s. Okay, so this you can, okay, well, we better apply the initial conditions. X of 0 is equal to 2, y of 0 is equal to 4. So we have s times big X of s minus 2 is equal to minus a half big X of s, and s times big Y of s minus y of 0 is 4 equal to a half X of s minus a quarter y of s. So what we've done is we've successfully written the simultaneous differential equations as simultaneous equations in algebra. Okay. Now what you can do is just solve the first one, find big X of s, substitute in here, solve for y of s, send both of them back. But as I said, I've said enough now. What we're going to do is we're going to write this as a matrix equation. So we've got all the x's on one side and all the constants on the other. And when I say x's, I mean x's and y's. So we'll take our time here. So you have s times x of s plus a half x of s equal to, add the 2 to both sides. I can do a bit more with that in a minute. The other one, take away the minus a half x of s. You've got plus s times y of s, and then add the quarter y of s to both sides, and then add 4 to both sides. And what I'm going to do finally, before I write as a matrix equation up there, I'm going to get all the x's together. So I'll do what you do normally, take out the common factor of x of s, so x of s times s plus a half, 0 y of s, which I'll write in. Now the fact that that's 0 makes this easier. In the other question it's not 0. You have to do what I'm going to do here. And then minus a half x of s, and then take out the common factor of y of s here. You'll get y of s times s plus a quarter equal to 4. Okay. So for the last time, it's easy to solve this. You can find x of s very easily, substitute it in here, and then solve for y of s, send x of s, send y of s back. Done. Question done. Right, now we're going to forget about that for now. Now, in the harder question, what you do is you write, once you have it in this form, you can write it as a matrix equation. So, what's the coefficient of x here? S plus a half. What's the coefficient of y? 0. What's the coefficient of x here? Minus a half. What's the coefficient of y here? S plus a quarter. Times big X of s, big Y of s, equal to 4. Okay. Now what we can do is we can use Cramer's rule to solve this. So Cramer's rule, you would have done a bit of last semester with the curve fitting. Okay, so x of s equal to dx divided by d. D is a little bit easier because d is the determinant of this. And remember what dx is the same thing, but you substitute the constants in for the coefficients of x. So instead of these, you have 2 and 4. And now you do right down diagonal minus left down diagonal. 2 by s plus a quarter minus 0 by 4 is just 0, so there's nothing to go there. Then s plus a half by s plus a quarter minus 0 by minus a half is just 0. So this is where we are. This is the thing to send back. Now, if you're looking at this, you say, oh, I want to send this back. It's not in the tables because it's all scrunched together. It's all multiplied together. And you say, oh, if I want to write it as a sum of simple terms, I need to use partial fractions. The bottom is factorized, so that's good. And then because they're both rule ones, you can do the cover up method. Now I'm not gonna do the cover up method here. You would need to do it in the harder example here. It's actually way easier because you've got s plus a quarter divided by s plus a quarter is 1. This is just equal to 2 divided by s plus a half. So if you actually did the cover up method, you get 2 over s plus a half plus 0 over s plus a quarter. So there's no real, well, you could do it, it wouldn't be wrong, but it's kind of a waste. And this we can send back 2 times e to the minus a half t. This is big X of s, it goes back to little x of t. Okay, now let's find y of s. Now the bottom is going to be the same, but the top is going to be a bit different. So y of s is dy over d. So the d is the same, s plus a half times s plus a quarter. Excuse me, times s plus a quarter. And now what is dy? It's the determinant of this, but instead of these things, you put these things. So I got s plus a half there, that stays there. Minus a half stays there. And then substitute in what are called the constants 2 and 4. So hopefully, if you get the harder question in your test, you remember your Cramer's rule from last semester. Okay, where are we? Yeah. Okay, so we have doing right down diagonal minus left down diagonal here. I get this is big Y of s is equal to s plus a half times 4 minus 2 by minus a half. All divided by s plus a half times s plus a quarter. Now this one, you could probably divide above and below by s plus half at this point, but it actually complicates something for later. I think the safest thing to do here is probably to multiply at the top and see where we are. So 4 by s is 4s. 4 by a half is 2. Minus 2 by a half, minus minus is plus. So you end up with 4 by a half is 2 plus 1 is 3. Okay, now you want to send this back using the tables. It's not in the tables because it's all multiplied together. So what we have to do is we have to factorize the bottom. We do partial fractions. I see a lot of us writing this, which is I think great. We understand we have to write this as some of simple things. First thing to do is factorize the bottom. That's done. There are distinct linear factors, and that means we've got 2 rule ones, and that means we can do the cover up method. That's good. So it's going to be something over s plus a half plus something over s plus a quarter. And what are we doing? Well, for s plus a half, cover up s plus a half. What have you got? You've got 4s plus 3 and s plus a quarter. And what do you put in for s? The value of s that makes this equal to 0, which is minus a half. Okay, we'll probably use the calculator on that in a moment. And then for the s plus a quarter, cover up s plus a quarter, and you have 4 times s plus 3 over s plus a half, and you substitute in for s after covering up the s plus quarter, the value of s that makes s plus a quarter equal to 0, which is minus a quarter. And we'll bang both of these into the calculator. So we get 4 by minus a half is minus 2 plus 3 divided by minus half plus quarter is minus a quarter. This comes out to be minus 4 over s plus a half. And then the other one, 4 by minus a quarter is minus 1. Plus 3 divided by half minus quarter is a quarter. 8. And we can send this back to little y of t. I don't like seeing equals here. Probably should be doing, if this is big Y of s, then little y of t is equal to, but I'm happy enough with this. So the minus 4 is fixed. then 1 over s plus a half e to the minus a half t, plus the 8 is fixed, and then e to the minus a quarter t. Okay, now that question, that specific question is made more difficult than I did it with methods more complicated than I needed with this, but what you should try and do is do this question without using Cramer's rule to see how easy it is, but be able to do Cramer's rule in case you get the question where you've got the other type of question where it's 2 objects in thermal contact. But this one, it can be done a bit easier than it's done. Okay, so that's going to be 10 marks out of the 40. Okay, so that's, doing that is 10% of your final grade. How bad? Then that is the question I would do first, by the way. I think I've put it down as question 1 because the most recent thing you'll have done, you know, with any degree of depth should have been Laplace transforms after doing the assignment, and obviously this is based on Laplace transforms, it uses Laplace transforms, so this is probably the question to do next. What question you do after this is it's a question of taste. So you've got chapter 4 and chapter 2. I'd say whichever one you've done more on. Maybe which one is easier is probably chapter 4. But what you might have done more on is chapter 2. I don't know. I'm going to do chapter 4 questions. So it's question 3. Now, see, these are in the video lectures. Okay, this is on page 227. Now, what you're going to get is you're going to get a double integral and a triple integral. So integrating over an area and integrating over a 3-dimensional shape. And usually one of them will have circular coordinates and one of them will have Cartesian coordinates. So one of them will be like a box and one of them will be like a circle or cylinder. And obviously you'll have to watch all the lectures and do some of the questions to figure this out. Okay. In this question last year, question 3A is going on about a semicircular disc. So part A is the circular coordinates and part B is it's going on about the massive box. It's the box. The box / rectangle / triangle is the easier question. Okay, what we got here? A semicircular disc is described by x squared plus y squared less than or equal to 4. Now the 4 is an area squared. This is kind of covered in the lecture. So this is 2 squared. And this, all the points whose coordinates satisfy x squared plus y squared less than or equal to 2 squared, that makes up a disk. So it's not just the circle, but also its interior. But it also says that the y coordinate is positive. So it's just the top of the disk. Okay, so we'll do a rough sketch of this. So radius 2, put just the top of it. So this is the area we're looking at. Okay, so it's a solid disk. Okay, so roughly sketch the region done. Where x bar y bar is the centroid, so the centroid is if it is uniform density, it is the center of gravity. Write down the x coordinate of the centroid. Now here, because it's symmetric, it couldn't be over here. It has to be along this line, okay, by symmetry. Now I've drawn it not quite symmetrically, but it's supposed to be symmetric. So it couldn't be over here because there's an equal amount of material on both sides. The centroid has to be along this axis here. So the x coordinate of the centroid is equal to 0. Because all the x coordinates along here are equal to 0. Okay, and then the second question is calculate the y coordinate, and the formulas will all be given to you. So it's the double integral over the region y dA over the area. Okay, The area you can just calculate as normal because it's a semicircle. So the area is now the area of a circle is pi r squared. This is half a circle, so it's a half pi r squared, and the radius is 2, so it's a half pi by 2 squared, which is equal to 2 pi. You can approximate that later if you want. Okay. Now what we have to do is we have to integrate y over that whole region. Okay. Now what we're going to do is we're going to find the contribution to this sum from a spoke. So that means we're going to add up from r equal to 0. So r is a different coordinate system, r and theta, where you use the angle made, so each point is given by the angle that it makes with the positive x-axis and its distance from the origin. And we want to add up y over all this region. We want to add up from r equal to 0 to r equal to 2. Okay. Now there's a few things, I'll write them down here. So we're changing from